Hello everyone, welcome to Pinstein Classes. So today we are going to discuss some important problems related to moment of inertia and the problems which are often come in JEE and NEET examinations. So let's get started. So in our first problem, it is asked to calculate the moment of inertia of a disk which is not uniform, which mass varies according to this value, and we have to calculate its moment of inertia about the center of mass. So suppose this is a disk and its center of mass lies at its center. So we have to calculate moment of inertia about this axis. So to calculate moment of inertia, what we will do is we will take a elementary ring which is at a distance r from the center, which will be r has width. Now to calculate it, what we will do is we will first calculate, and then we will see what we have to do. So to calculate moment of inertia, we know the formula as we learned in our last lecture, that is dm times r square. So what is dm? Dm is nothing but the area of this small segment times sigma, because this is mass per unit area. This sigma is nothing but mass per unit area. Now this is r square. Area is nothing but the area of this segment is nothing but this width is dr. So dA, area, small area, will be 2 pi r times dr. So we will plug here the expression for dA, 2 pi r times dr, and the value of sigma is k times r square. So we will plug here. We will take this k, 2 pi outside of this integration, and r square r4 times r5 will be left inside the integration times dr. This will be 2 pi k r6 upon 6, and the limit will go from 0 to r. So we will plug the value here, and it will be 2 pi k r6 upon 6. Now what we have to do is we have to find out this value of this k, and then we will get the answer. So to calculate the value of this k, what we will do is we know that total mass is given as m, and total mass is integration of a small dm. Small dm is nothing but sigma times dA integration, and dA is nothing but 2 pi r times dr. So we will take out 2 pi from the integration. We will plug the value of this sigma. So it will be k times r square times 2 pi r times dr. Again we will take out this all the constant from the integration. So 2 pi k will be outside the integration, and it will be r cube times dr. The integration will go from 0 to r. So 2 pi k r4 upon 4 from 0 to r, and this will be 2 pi k r4 upon 4. 2 and 4 will be cancelled out, and this is total mass. So K is nothing but 2 times m upon R4. We will plug this value of K in our earlier expression. So moment of inertia about the center of mass will be 2 pi times 2m upon R4 times R6 upon 6. 2 will be cancelled out with this 6. R4 and R6 will be R square. So this expression will be nothing but this expression will be, here also pi will be come in denominator. So pi and pi can also be cancelled out. So this expression will become 2m times r square upon 3. So option D is correct. Now in this problem it is asked that we have a disk of radius r. A small disk of radius r upon 2 is cut out from the bigger disk, and now we have to calculate the moment of inertia of this remaining part about the center of the disk. So to calculate this moment of inertia, what we will do is, we know the moment of inertia of a disk is nothing but mr square upon 2. This is our general formula. Here the disk has a total mass of 9 m. So the moment of inertia of the whole disk, the moment of inertia will be total of the total disk it, let it be it, it will be 9 m, and r is r upon 2. So this will be moment of inertia of the total our moment of inertia of our total disk. Now what the concept here is, we just subtract the moment of inertia of this cutout portion from this total moment of inertia, and we have done. Now the moment of inertia of this cutout portion about this axis, about this center of mass will be, so first let us calculate moment of inertia of this cutout portion about its center of mass, about its center. So it will be nothing but, so it will be m upon 2 times r upon 2 square. So this will be m upon 2 r square upon 4. So this will be mr square upon 4. How the mass of this cutout portion is m upon 2? You can explore yourself. Otherwise, if you have more doubt, you can contact me on my email. So the moment of inertia of this cutout portion about this point. So we have to shift this moment of inertia of the cutout portion from its center of mass to the center of mass of the original disk. So the shifting distance is 2r upon 3. So we will apply here the parallel axis theorem. So mr square upon 4, this will be mr square upon 8. So mr square upon 8 plus m times 2r upon 3 square. So the total moment of inertia of this cutout portion will be mr square upon 8 plus m times 4r square upon 9, and we can simplify it further. So the moment of inertia of the remaining portion will be total moment of inertia of the disk minus moment of inertia of the cutout portion. So this will be 9 mr square 9 mr square upon 2 minus mr square upon 8 plus m times 4 r square upon 9. You can do this calculation by yourself and you will reach to the answer 4 mr square approximately, and this will be your answer. Let us move for the next one. In this problem, it is asked to calculate the moment of inertia of a solid sphere about an axis which is parallel to its diameter, and we have to show the variation. All right. So suppose this is the diameter, this is the axis of the diameter of the sphere, and we have to calculate its moment of inertia on different points which are parallel to this diameter. Suppose I am taking one point, one line which is at a distance x. So the moment of inertia of this sphere will be, let it be, we know the formula, 2 upon 5 mr square. So about this axis which is at a distance x from the center of mass, the moment of inertia will be, I prime will be 2 upon 5 mr square plus m times, we will use parallel axis theorem here, x square. So when x is 0, I prime will be 2 upon 5 mr square, which is minimum, and on changing the value, I prime will directly proportional to x square. So this will be parabola. So only this option is matching. In this problem, it is asked that two identical spherical balls are given, and a rod which length is 2r, and we have to calculate the moment of inertia of this whole system about the center of mass of this rod. So how we are going to do it? First, we know the moment of inertia of the sphere. We know the moment of inertia of this sphere. We will use parallel axis theorem to transfer the moment of inertia of both the spheres about this axis, and we know the moment of inertia of this rod, and then after we are going to add all of this. So we will get the answer. So let us see how we are doing. So the moment of inertia of this sphere will be 2 upon 5 mr square. So if we transfer it at a distance 2r, so the new moment of inertia, let it be I1, let it be sphere 1, let it be sphere 2, and for rod, let's give a number that is 3. So I1 will be 2 upon 5 mr square plus m times 2r square. So this will be 2 upon 5 mr square plus 4m r square. This will be 22 upon 5 mr square. This will be I1. Similarly, I2 will also be 22 upon 5 mr square, and the moment of inertia of this rod will be, moment of inertia of this rod will be, we know the moment formula for rod, that is ml square upon 12 if the rod length is L. The formula for rod is ml square upon 12. So here L is 2R. So we will plug here 2R times square upon 12. So this will be M times 4R square upon 12. This value will be cancelled out. This will be mr square upon 3. So the total moment of inertia will be I is equals to I1 plus I2 plus I3. So this will be 22 upon 5 mr square plus 22 upon 5 mr square plus mr square upon 3. We will take LCM. So this will be 44 upon 5 mr square plus mr square. So when you will take LCM, this will become 15, 5 3 times, 44 3 times. 132 mr square plus 3 5 times 15, so it will be 5 mr square. So the total value is 137 upon 15 mr square. So option A is correct. Let us move for the next problem. In this problem, it is asked to that a thin circular plate of mass m and radius r has density varying as rho is equals to rho naught times r, where density is varying with r. So the moment of inertia of the circular plate about an axis perpendicular to the plate passing through the edge is I is equals to mr square. We have to calculate this value of this A. When this problem came in 2019 means they gave the wrong answer. The correct answer was 16 upon 15. So we will calculate it, how it is 16 upon 15. First, as we did the disk problem, that we considered a small mass which is at a distance, let the radius be x and of width dx. So dm will be nothing but rho times mass is distributed on area, so it will be rho times dA. Here it should give sigma, but it is given rho. Don't worry about it. So rho naught times x and yeah, so rho times this is a small area A, yeah. So it will be rho naught times x times 2 pi x times dx. I have discussed in the even first problem how we are calculating this dm. We will plug this value to calculate our rho naught and then we will get the answer. So the total mass is m. So it will be integration of dm. So rho naught 2 pi x square times dx. We will take 2 pi rho naught common. So x square times dx, integration will go from 0 to r. This is capital M. We are trying to find out the value of this rho naught. because it is not mentioned in our final expression, so that we have to find it. So m times 2 pi rho naught r cube upon 3, and rho naught will be 3m upon 2 pi r cube. So we are going to use this value of rho naught later on. Now let us calculate. It is asked the moment of inertia of circular plate perpendicular to the plate and passing through its edge. So it is asked to calculate the moment of inertia is passing through this edge. First we will calculate about the center, and then we will calculate about the edge. So about the center, let it be I naught. So I naught will be nothing but integration of dm times, if we have considered here x, so it will be dm times x square, because this is the elementary length I have discussed in the previous problem, which radius is x and width is dx. So we will plug here values, the value of dm, rho naught x, 2 pi x, and dx, x square. So we know the value of this rho naught, we will plug later on. Rho naught 2 pi will be came out of integration as their constants, x times x square. So this will be x4 times dx, and integration will go from 0 to r. So rho naught 2 pi r 5 upon 5. Now I naught will be nothing but rho naught, we will plug the value of this rho naught, 3m upon 2 pi r cube times 2 pi r5 upon 5. 2 pi and 2 pi will be cancelled out, r cube and r5 will be cancelled out, it remains r square. So 3m r square upon 5, this is about the center of mass, but it is asked to calculate the moment of inertia about its edge, so we will use parallel axis theorem here. So about the edge, the moment of inertia will be 3mr square upon 5 plus m times, we are shifting at a distance r square. So this will be 8 upon 15 mr square. I think this should be the actually this option was incorrect during the 2019 mains. So the answer will be 8 upon 15 mr square. Option C is correct. So this is all for today. Next we are going to find out, we are going to learn the concept of angular momentum. Hope we will meet in the next class. Bye.